Hi everybody, in this video we are going to be talking about unit 11.1.1 and it is going to be exponential notation. So that's a topic we're going to be working on. And I'm going to get my screen shared here. All right. So for this topic, what we're going to do first is we are going to work on expanding those examples that you see. So I'm hoping that you at least remember that exponential notation, it's a fancy word for saying repeated multiplication. So we're just repeating multiplication for these. So when we are expanding them, we are just going to look at the first one and it says x to the third times x squared. So we're going to take x times x times x. And then the next one is going to be x times x. So we've got all of those just written out. Then our next one, we've got x times x. We've got two of them times 3y's times a z. Number 3 is a common error that will occur on that one. And students will often try to write equals x squared plus y squared. And that's not true. So they'll just try to distribute that 2 across. And you can't distribute it across when we have addition or subtraction going on in between those terms inside the parentheses. So you can only do it like if you had something like xy and we're squaring it, then you can definitely distribute that exponent of 2 in and you could get x squared y squared. That's okay, but not ever when it's addition or subtraction. So on this one, we're actually writing out that quantity of x plus y times x plus y. And then if we were to FOIL it, like take the first terms, outside terms, inside terms, last terms, and multiply it. So if we're going like this, and we're multiplying, and then we're simplifying and combining like terms, I don't know if you remember, but that term's called a perfect square binomial, and it results in a perfect square trinomial. You're taking plus xy plus y squared when you're multiplying them all out. And then you combine these two terms, and you're going to have x squared plus 2x squared, 2xy plus y squared for that one. And again, when we're just expanding, this is what you need for just expanding it. So then our next example over for number 4, we've got x times x plus y times y times y. And then careful on 5 and 6. This is going to go back to what we were talking about in order of operations. Here, this is the same as -1 times z times z times z times z. And then the next one, we're doing -z times -z times -z times -z, and we've got 4 of them all written out, and that negative is included inside the parentheses that time, so that is why we're including it when we're multiplying it out by itself 4 times. All right, so the next one, it says evaluate the following. Evaluate means that we're taking whatever they gave us for x and we're plugging it in for that x, and we're evaluating that expression for when x actually equals 2. And so that's what we're going to do. And so we're going to take this, and we're going to take 5 times, and I normally put parentheses around it, and then I put my exponent on the outside. And so follow your order of operations. So what's going to come first? And it should be your exponents, right? So exponents are going to come first. So 2 times 2 times 2 is going to give us 8. And then 5 times 8 is going to give us 40 for that one. And then coming down here to number 2, if we do 5 times, and again, you're plugging in that -2 in for x, and then we are cubing that entire value. And here we're going to get a -10, and then we're cubing it. And then you've got a negative times a negative times a negative, which means our answer is going to end up being negative. And then 10 times 10 times 10 is going to end up giving us 1,000. I almost said 10,000, but that wouldn't be true. So it's going to give us 1,000. All right, so then our next one for number 3, we're going to be plugging in -3 and we're raising it to the 4th power. And you can plug that into your calculator if you'd like, or you can think about, well, what's -3 times -3? We know how to do that, right? That's going to be 9. And then if you take another -3 times another -3, that's going to give you a +9, which is going to give you 81. So just showing you how you can write it out as well. All right, so our next one, we're going to do -2, and we're going to multiply it by -3 quantity squared. And -3 quantity squared is going to give us a +9, because remember, you're taking like -3 times another -3, and then which is going to give you +9. And then you're taking -2 times a +9, which is going to give you -18 for that one. All right. So for this next part, it says discovering properties of exponents by looking at a pattern. Okay, fine. So looking at our exponential form versus our expanded form versus when it's evaluated. So here our expanded form, if we're just expanding it, is going to be 2 times 2 times 2 times 2. And then your 2 times 2 is going to be 4. And then the other one's going to be 4, which is going to give you 16. And then this one's going to be 2 times 2 times 2, which is going to give us 8. And then we're going to get 2 times 2, which is going to give you 4. And then 2 to the first, how are we going to write that? We can just write it 2. It's 2, it's going to be 2, not times anything. It's just 2 to the first. And then evaluated, we're just going to rewrite the same thing. So I want you to look at the pattern that's occurring over here for every single time. And a lot of times if I were in class and I'm asking you this, you would say, well, it's being multiplied by 1/2, or we're dividing it by 2. Every single time is exactly what's happening. So then 2 to the 0. Sometimes students will give me the answer like, oh, that's 0. Well, look at the pattern. So look at the pattern. Is it going to be 2 divided by, if we take this 2 right here and we divide it by 2, like we follow this pattern, 2 divided by 2 is going to give us 1 here. So that means, and here I'm just going to write 2 to the 0 for that one. So we just write 2 to the 0, and then our evaluated form of that is going to be 1. So any non-zero number raised to the 0 power is going to equal 1. So then what's 1 divided by 2? 1 divided by 2 is going to give us 1/2, or you could write 0.5. What if you take half a pi and you divide it in half again? It's 1/4. And if you take 1/4 of a pi and you divide that in half again, you're going to get 1/8 here. And so, well, how do we write that in expanded form? Well, in order to make something where you have a number and you have it's being raised to a negative power, you're going to make it so it's 1/2 to the first, and 1/2 to the first is just going to be 1/2, right? So 2 to the first is 2. And then this next one would be 1/2 squared, which is going to give us 1/2 times 1/2. And then this last one would give us 1/2 to the third, which is going to be 1/2 times 2 times 2 for that one. And just writing it out in expanded form. So then looking at the right-hand side, this is one I want you to try on your own. So you're going to, when we do our notes check, you're going to need to make sure that that's filled in. So that one I would like for you to try on your own and fill out the expanded form and fill out the evaluated form and see what you get. And then once you've done that, I want you to come here and think about this question. So what would happen if we did the chart above for 0 as the base? How could it look similar? How could it look different? And why? So if you think about that, so I'm just going to draw a little bit right in here. So if I did 0 squared, 0 to the first, 0 to the 0, and 0 to the -1, I'm just going to try those. So this one in expanded form would be 0 times 0, which is 0 for the evaluated form. This would be 0, this would be 0. But 0 to the 0, so 0 to the 0 you would expect based off of our pattern that we've got going would be like is it a 0 here? Is it a 0 here? But what's happened on the other ones? When you've taken the number and you've raised it to the 0 power, it's equaled 1, right? And so on this one, it's going to end up being undefined. So if we're taking 0 and we're raising it to the 0 power, we don't get 0 here because we end up getting an answer that is going to be undefined. And we're going to explore the why behind that in our next lesson. Then here, if we looked at 0 to the negative first, well, how would we rewrite that, right? To have a positive exponent, it would be 1 over 0 to the first. Can we have 0 in the denominator? No, it doesn't make sense to take the number 0 as a whole part and to divide it into parts because it's 0. We're not going to divide it into parts for a fraction. So this also is going to be undefined if you are raising 0 to a negative exponent. So I just want to point that out. All right, so then we've got our rules that can be concluded from that. Get out my next piece of paper. So rules that can be concluded, we've got any number or variable A. So any number or variable. I need to give myself a little bit more space. So any number or variable A raised to the power of 1 is the number itself. So like A to the first is going to equal A. Then the next one, it says any non-zero number or variable A that is going to be raised to the power of 0 is going to be equal to, let me get this in here, is going to be equal to 1. And so if we have A to the 0, and that's going to equal 1. And I'm hoping you notice that it says that A has to be any non-zero number or variable. Because again, if A was 0, it's going to be undefined, which comes in the next one. So the quantity of 0 to the 0 is undefined. And then for any non-zero number A and any integer M, we have A to the negative M. Well, to rewrite that so it has a positive exponent, we're going to do 1 over A to the M. And if similarly, if we have this situation where we've got 1 over A to the negative M, in order to make that exponent positive, you just bring it to the numerator. So this one is going to be A to the M. And so for example, if we've got 5 to the negative second power, we would write 1 over 5 squared, which is going to give us 1 over 25. And then using that second part of that rule again, if we have 1 over 5 to the negative second, and we're like, wait a second, we want to write it with positive exponents, we can write it as 5 squared. Because again, they trade places, right? It'd be 5 squared over 1, but 5 squared over 1 is just 5 squared. And then that would equal 25. And so that gives you that rule. All right, so let's look at number 5. So for number 5, it says for any non-zero numbers A and B and any integers M and N, and remember integers are positive or negative whole numbers, so no fractions. So that might be something you write down if you don't remember what integers are. It's positive or negative whole numbers. So if we've got any integers M and N, and we have A to the negative M over B to the negative N, our result, if we want to rewrite this so it has a positive exponent, we would put B to the N in the numerator, right? And then if we want this one to have a positive exponent, it moves down to the denominator. And so it would be A to the M. And that's how you're going to apply that rule. So for example, if we had something like 2 to the negative third all over 1 to the negative fourth, then I said, okay, I want you to rewrite this and then evaluate it so it has positive exponents. I would want you to bring this to the numerator, and it would be 1 to the fourth all over, and then this goes to the denominator, it would be 2 to the third. And so 1 to the fourth is just going to give us 1, and 2 to the third is going to give us 8. like that. And then on our next one, if I give you x, if I say x to the negative third, y to the negative fifth, z squared. So if I give you something like that, and again, I say I want you to rewrite it so it has positive exponents all throughout. So x is going to go to the denominator. These two guys are going to switch. The z can stay right where it's at because it already has a positive exponent, right? So here we can do y to the fifth all over x to the third z squared. And then that would be our answer, your final answer for that one. All right, so then for number 6, applying that rule. For any non-zero numbers a and b and any integers m, if we have the quantity of a over b and it's raised to the negative m power, our rule states that we can just go b over m, or I'm sorry, not m, b over a raised to the m power. So it's going to be positive. Well, why does that work out? Because if we did an intermediate step in here, and we did, okay, well, let's go ahead and distribute that to both terms. We would have a to the negative m all over b to the negative m. And then if I said, okay, now I want you to rewrite it so it has positive exponents, you would switch these two around and you would do b to the m all over a to the m, which is exactly what we have here as well. It's just that the m is distributed into those terms. So then kind of applying some examples here, if we've got 2/5 and we're raising it to the negative third, here we would go ahead and write 5 over 2, and we're raising it now to the third, which is going to be 5 to the third all over 2 to the third, and that's going to end up giving us 125 over 8 for our final answer. So that's how you're applying that rule. The next one, if we've got 5/4 and we are multiplying it, or we're raising it to the negative second power, again, you're just switching the numerator and the denominator, and that makes it positive. So then you've got 4 over 5, and we're squaring it. So that's going to be 4 squared and then 5 squared. So it's going to be 16 over 25 for your final answer. And again, we look at those typically and see if they are something we can reduce, but both of those fractions, the first one that I did and the second one, you can't reduce them. So we're done, which is why I circled those. All right. So for this example, we are just, it says evaluate 3x to the 0 minus y to the first when x equals -6 and y equals -2. So we're going to do that. So 3 times -6 to the 0 minus y, oops, I need to do an actual number in there, minus -2, and we're raising it to the first. So again, we're plugging this in for y, and we're plugging this in for x. So here, -6 to the 0, again, what does that equal? Does that equal 0? Does it equal 1? And I'm hoping you're all thinking in your heads 1. So even though it's a -6, it's still going to be 1. So we've got 3 times 1. Then we have, we have -2 to the first, which is going to just give us -2. So we've got minus a -2. And then 3 times 1 is going to give us 3, minus a negative is going to give us a positive, and 3 plus 2 is 5. So that's our answer there. So what I would like you to do too, I want you guys to try this one and see what you end up with. Make sure you're showing your work and your steps. What you should be getting at the end is 1 over 64 for your answer. So plug in the -8 and for x, and then I want you guys to go through the steps. Rewrite that x to the -2 so it has a positive exponent, and then evaluate the rest and see how you do on that one. All right. Flip my paper. So on this one, we've got 4 different tables here, and we're just asked to identify what's the base, what's the exponent, and then simplify it. So the base on the first one, first problem is just going to be 9, and the exponent is 0, and 9 to the 0 is just going to give us 1. And then our next one, if we have -9, so think again about it being like this. And so in that case, our base is still going to be 9, not -9. And then our exponent is 0. And then thinking about how we have -1 times 9 to the 0. So that means we've got -1 times 1, which is going to ultimately give us -1 for our answer. Then when we've got that -9 and it's raised to the 0 power, our base, because we've got parentheses, is going to be -9 and our exponent 0. And we're taking that entire quantity, we're raising it to 0, which means our answer is going to be 1. Then for our next one, our base is going to be -9, our exponent is 0. And again, think about this being kind of like this, -9 to the 0. And so this would be like -1 times 1, which is ultimately going to give us -1 here. I'm just going to bump over to number 5 since it's right here. So on number 5, we've got the quantity of -8x as our base because that entire quantity is being raised to the 0 power. So that's why it's both of those things are the base. So we've got -8x and the power is 0. Because both of those things are in parentheses and they're both being raised to the 0 and we only have multiplication going on right here, it's not addition or subtraction. When we raised those two to the 0 power, you could also rewrite it like this if you wanted. Times x to the 0. So then you would be like, oh, well, that's 1 times 1, which is going to give me 1. You also can just look at it as it's a quantity and it's all being raised to 0, which means it's going to be 1. That's also fine. So same thing here. We've got 8x and then we've got 0, and that's going to give us 1. Here our base is only x because we don't have parentheses around that entire quantity. The exponent is 0. And so we're going to have 8 times x to the 0. And so we've got 8 times 1, which is going to ultimately give us 8 for our final answer. And then for our next one, we've got x as our base and 0 as our exponent. And so we've got -8 times 1, which is going to give us -8 for that one. And so now we're ready to look at kind of our last two examples here. Get this out of the way. All right, so our base for our next one, again, is just going to be 1/3. The exponent's going to be -1. So again, how do we rewrite that so that we can make it positive? And you're supposed to flip-flop them. So you flip-flop these two. So then you've got 3/1. We're raising it to the first, and that's just going to give us 3 for that one. Then our next one, we've got -1/3 as our base, and then we've got our exponent of -1. And so again, on this one, we're just flip-flopping them, right? So this is another common error. So please make sure you're not making this error. So I've had it before where students, they switch these two and then they make the -1/3 +1/3. That doesn't change the negative on the actual number, just changes the negative on the exponent. So now we're going to have -3/1 raised to the first power, which is just going to give us -3 for that one. Next one, our base is 1/3, our exponent is -1, and so we're going to end up getting negative, and it's going to be 3/1 to the first, which is going to ultimately give us -3. And then the last one on this one, our base is -1/3, our exponent is -1, so we're going to have the negative out front. We're going to make the ones in the middle, or sorry, the ones in the parentheses, the numerator and denominator switch places. And then that's going to give us a positive exponent. So then essentially what we have right now is a negative times a -3, which is going to give us a +3 for our final answer. And then our one. And again, I would try to pause this, like pause it, try this out, see how you do, and then check my work when you're done and see if our answers match up. Okay. So base is going to be -2/5. Exponent's going to be -2. In order to make it positive, we're going to have -5/2, and we're going to square it. And then you can think about having like -5 quantity squared all over 2 squared, which is going to give you 25/4. Because you have -5 times another -5, which is going to be +25. And that's still going to be all over 4. All right, next one, we've got our base of 2/5 and then our exponent of -2. And so then switching it up, you're going to have 5/2. And you're raising it to the positive second, which is going to give you 25/4. Our next one, we've got -2/5. And we're raising it to the -2nd power. So we've still got that negative out front. We still have the negative inside the parentheses. We're just switching the order, changing numerator and denominator. Our exponent becomes positive now because we did that. So again, we still have our negative out front. We've got -5 quantity squared all over 2 squared, which is, in the numerator, it gives you a positive 25/4, but then don't forget this negative. So then you end up with -25/4. And the negative on our answer comes from this negative right here. That's where that negative is coming from. This one ended up turning positive. All right, last one. Base is 2/5. Our exponent is -2. And then we've still got that negative out front. And then we are going to change this to write 5/2, and we're squaring it. So here's our negative out front, and we're going to have 25/4 for our final answer. So I believe, let me check my next page. That is it for exponential notation. Thanks for tuning in.